Hello, young grasshoppers. This is page 3 of the Unit 3 study guide for standard. The first question is, or number 5, I guess, from ELR 3.2 to 3.4. Which two quantities are measured in the same unit? So let's just go ahead and write out the units for these. So velocity is measured in meters per second, and acceleration is measured in meters per second squared. Okay? Weight and force. Weight is a word that means the force caused by gravity. It's measured in newtons, and force is also measured in newtons. So B is the correct answer, but I want to make sure that we understand why C and D are not the correct answer. C is mass and weight. Mass is measured in kilograms, and weight is measured in newtons. Now, in the United States, weight is measured in pounds, but when we talk scientifically, we measure weight in newtons, okay? Force and mass. Force is measured in newtons, and mass is measured in kilograms. So the only answer could be B. All right. Number 6. David is pushing on a laptop cart with a force of 150 newtons. Will is pushing back with a force of 200 newtons. The mass of the cart is 125. So my first step is to draw a net force diagram that shows all the forces. Figure out the net force, and then answer whether or not it'll accelerate. So I'm actually doing 3 things in this question, so I want to be really careful. So draw a net force diagram. So I can draw a box or a dot, whatever. And I've got the force of David going this way, and it's 150 newtons. And I've got the force of Will going this way, which is 200 newtons. So there's my net force diagram. If I want to figure out the net force, I've got 200 in one direction and 150 in another direction. So I use my sum, my net force, remember that means sum of, S-U-M. My net force equals 50 newtons. Will the cart accelerate? Yes, it will accelerate because not all forces cancel out. Okay. All right. What is the difference between static and sliding friction? Static friction has to do with object standing still. So when you're trying to get something pushing, static friction is what's working against you. Sliding friction is a moving object when the two surfaces are directly sliding up against each other. Okay? Fill in the statements with a greater than, less than. So sliding friction is less than static friction. It's harder to get something moving than it is to keep it moving. Sliding friction is greater than rolling friction. Remember the bucket that we put on all the pencils? Okay, it was easier to roll or to move when it was rolling. Nope, Zev, it's not bedtime yet. All right, sorry. Zev is watching Frosty the Snowman right now. That's your secret question you should be able to answer if you've watched this video. That's how I'll know. Okay, so now let's talk about ELR 3.6, which is mass versus weight. Okay, remember mass is the amount of stuff in an object, and weight is the force on that stuff. Okay, mass doesn't tell us anything about the force on it. It's the amount of stuff. All right, so let's look at this. On Earth, an astronaut steps on a mass scale that says 103 kg. By the way, up here, you get different accelerations on different planets. Okay? So, what is her mass on Earth? Well, just told you, 103. But I know that her mass is the same no matter where she is. So I'm actually going to go through and fill in the mass for all these. Because no matter where she goes, Earth, Mars, Jupiter, the moon, wherever, it's always going to be 103 kg because she's made up of the same amount of stuff. What's going to be different is her force, or the force of gravity. Another word for that is weight. So F equals ma. So to find the weight or force, I take 103, and it's on Earth, so times 10. And I get 1,030. Okay? Her weight on Mars is, you're going to have to do the math on this because I don't have my calculator out, 103 times 3.8, which is the acceleration on Mars. Okay? Oh, and this is newtons, by the way. So fill this number in, whatever the final answer is. You'll have to multiply those two numbers. And what is the weight on Jupiter? 103 times 26.6. So once you get that answer in your calculator, that should be measured in newtons, okay? The point is this, the force on Mars is going to be less than on Earth. All right, actually, hold on, I might have those answers. Maybe I can fill them in for you. Let me look at my papers here. Of course I can't find it when I want to. It's gotta be this one. All right, never mind, I found it. So on Mars, it is 391.4, and on Jupiter, it's much greater. It's 2,739.8 newtons. Okay? All right, last ELR. What does Newton's third law tell us about the motion of an object? And a roller skater pushes off of a wall and goes backwards. How does this show Newton's law? So I'm going to show you the answers here. And here they are. So, Newton's third law tells us that for every action, there is a reaction, and it's equal and opposite direction. And then, a roller skater pushes off of a wall and goes backwards. How does this show Newton's third law? The roller skater pushes on the wall, and the wall pushes back. There's less friction between the ground and the skater than there is between the wall and the ground because the wall's stuck. So the skater is what moves back. Although, when that skater pushes on the wall, right? When that skater pushes on the wall, I gotta give him roller skates. There's some force on the wall. The wall feels the force. It's just the wall is stuck to the ground. So because it's stuck to the ground, it stays put, and that's why you don't see it move. Okay? But then the wall pushes back on the skater, and that's why you see the skater going backwards. All right, so I want to make sure that you understand the last thing that you need to do. So I hope you're still paying attention. So when you went through, you were supposed to correct mistakes or add to your questions in a different colored pen or pencil. You were supposed to put a star next to the ones that you got right, that you didn't have to add anything to. And now I want you to go through and I want you to circle the hardest ELR and the easiest ELR. Okay, so you can just circle this where it says like ELR 3.6, you can just circle that. Now, if you did everything right and you don't have anything written in, then maybe you're just going to go by your feelings as you did it. Like, oh, I felt like this was the hardest. I felt like this was the easiest. If you got some like different colored pen written all over your paper because you made some mistakes, then it should be pretty clear. The one with the most pen was probably your hardest, and the one with the least amount of writing in a different color was your easiest. Okay? The last thing is the secret word of the video, so I know that you watched it, and it is cyclone with a smiley face. Now, don't go telling other students that didn't watch the video. I want to know whether or not they watched it based on that. You should also be able to tell me what Zev was watching on YouTube. All right, have a great day. Bye-bye.